Recall from a previous algebra course that if a polynomial function f is factored completely, we may solve the equation f of x equals 0 using the zero factor property. For example, if we have a function f of x equals x minus 1 squared times x plus 3, if I put a 0 in for f of x or set the function equal to 0, and I set my factors equal to 0 using the zero factor property, I know that I'll have two solutions, x equal to 1 and x equal to negative 3. So these are the solutions of the equation f of x equals 0. If we graph this function, hopefully we remember, on a standard viewing window there, you can see that it has two x-intercepts. One looks like it's at negative 3, and the other one certainly looks like it's at 1. So if we make a little sketch, if we remember this important property that the solutions correspond, so at 1, 0 and negative 3, 0, these are the x-intercepts of this function. So the solutions of the equation f of x equal to 0 correspond to the x-intercepts of the function. So we can see the solutions to the equation f of x equal to 0 correspond to the x-intercepts of the graph. Other names for x-intercepts, we'll use zeros or roots of the function. So those solutions, those x-intercepts, are also called zeros or roots. So we can summarize. The following four statements are equivalent. They're saying the same thing. If r is a real zero of the polynomial function f, and real, we will talk about non-real solutions later, but for now we're talking about real zeros. So if r is a real zero of the polynomial function f, that means then that r is an x-intercept of the graph of f, and then x minus r is a factor of f, and finally that also means that r must be a solution to the equation f of x equals 0. And this is a very powerful relationship, these four different ways of saying the same thing, and we'll come back to this several times in this chapter.